Okay, ladies and gentlemen, today we're going to be talking about solving some trig equations. Remembering solving equations means we're looking for the value of the variable. So I have a few trig equations I want to look at here. The directions will always say, at least in the problems we're going to be doing, solve for theta between 0 and 2 pi, including 0, not including 2 pi. So what does that mean to us? It means this: find all values of theta in the interval 0 to 2 pi, including 0 but not including 2 pi, that satisfy the equation. Okay, and it's very different from inverse functions, and I'm going to show you that here in a few minutes. So let's look at example 1. It says 1 minus the sine of theta equals 1/2. I want to find all the values for theta that make this equation true. So just like when we solve equations algebraically, we isolate the variable. In this case, we're going to isolate the trig function. So I'm going to first start by subtracting 1 from both sides. So I have negative sine theta equals negative 1/2. Then divide both sides by negative 1, so I get the sine of theta equals 1/2. So what this is asking me is to find all the values of theta in the interval 0 to 2 pi where the sine is 1/2. So getting out my unit circle, I'm going to simply look on the unit circle for all the values between 0, including 0, all the way to 2 pi. Remember, this is back to 2 pi, where the sine of theta is 1/2. And so remember, the sine's the y value, so the answer to this question is pi over 6 and 5 pi over 6, and that would be it because the sine values would be negative in the third and fourth quadrants. So the answer to this problem is theta can either be pi over 6 or 5 pi over 6, and we write it in set notation. Okay, now if you look at videos on the internet, you're going to see something like this. They're going to take this and they're going to sine inverse both sides of the equation. So it would read theta is the sine inverse of 1/2. I do not particularly like that notation because remember, sine inverse has a range of negative pi over 2 to pi over 2, and that's not what the directions are saying here. This is a very different statement than this. This is saying, when you use the sine inverse notation, it's saying find all the values between negative pi over 2 and pi over 2 where the sine is 1/2. And that's not what we're doing here. The directions are very specific in that I want all the values between 0 and 2 pi. So I don't really like using the inverse notation here in these problems. Okay, so next problem. Again, isolate your trig function. So I'm going to subtract the 3 from both sides to get 0. Divide both sides by negative 1, I get the sine of theta is 0. So I'm looking for all the values between 0 and 2 pi, including 0 but not including 2 pi, where the sine is 0. So back to my unit circle here, you can see that the sine would be 0 here at 0. It would be at pi, and then we're not going to go back around and include 2 pi because that's not included in our directions. It's 0 to 2 pi, not including 2 pi. So the answers are 0 and pi. Okay, so another quick type of problem. Again, I'm going to isolate the trig function. So I'm going to first add the 3 to both sides. I'm going to divide both sides by 4. And then I'm going to square root both sides. But remember, and this is the thing that most people forget, when you square root both sides of an equation, you always need to put plus or minus. And I'm going to break this up into the square root of 3, and then the square root of 4 is 2. So now I'm looking for all of the angles, and remember the directions are going to say between 0 and 2 pi, all the angles between 0 and 2 pi that satisfy this equation. So what are all the angles between 0 and 2 pi where the cosine is positive or negative square root of 3 over 2? So back to my unit circle. It's pi over 6. Remember, cosine is your x value. It's also 5 pi over 6 because that's negative. It's also 7 pi over 6. And it's 11 pi over 6. So it's 4 answers. There are 4 values of theta that satisfy this equation. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. 4 solutions to that equation. Okay, so the reason I showed you that one is to remember that when you square root both sides, don't forget to put plus or minus or you will be missing some solutions. Okay, let's take it a step further. We're going to use what we know about algebra to solve some of these more complicated problems. So here we go. This should look familiar to you. It should look like a trinomial. If I change this to 2x squared, just for the sake of visualization that this is a trinomial, 2x squared minus 3x plus 1, how would we go about solving this one? Well, we would factor it, and we would factor it into 2x minus 1, x minus 1. And then we take each factor and we set each factor equal to 0. So we say 2x minus 1 equals 0, x minus 1 equals 0. So x is a half, or x is 1, and we get 2 solutions. Okay, now it's not x, it's the sine of theta is actually our variable. So how this guy, I can take this as a sample of how this would factor. This would factor into 2 sine theta minus 1, sine theta minus 1. And just like you do with trinomials, or when you factor, is then you just set each factor equal to 0. So I would set 2 sine theta minus 1 equal to 0, and sine theta minus 1 equal to 0. This would give me the sine of theta is a half. This would give me the sine of theta is 1, and I need all the theta, and remember the directions, between 0 and 2 pi that satisfy this or both. So theta would equal, so where's the sine a half? The sine is a half at pi over 6 and 5 pi over 6. And then where's the sine 1? At pi over 2. And you have 3 solutions to that problem. Okay, so we apply sort of all those things we know about solving equations to solving trigonometric equations. So let's look at the next one. The next one has sort of a little bit different twist on it. If you notice, this equation, all the equations we had before had either sine or cosine. This one has both sine and cosine. And it's really difficult to solve these when there's 2 trig functions involved. So what we want to try to do is replace one trig function in terms of the other. And this trigonometric identity is going to be probably your best friend through trig. Sine squared theta plus cosine squared theta equals 1. It's called the Pythagorean identity. And this is true for any angle theta. If you take any angle theta and square the sine, square the cosine, and add them, you will always get 1. And it simply comes from Pythagorean theorem. So you could probably just look at it and see the relationship to Pythagorean theorem. But what I can also do is rearrange this equation. In other words, if I took this equation and subtracted cosine squared from both sides, cosine squared theta. It would read sine squared theta equals 1 minus cosine squared theta. Now what does that do for me? Well, what it allows me to do is take this sine squared theta and replace it with 1 minus cosine squared theta. That way my equation will all be in terms of cosine, and I'll only have one trig function instead of two to try to solve for. So I'm going to do that right now. So sine squared theta I'm going to replace with 1 minus cosine squared theta equals 2 cosine theta plus 2. So I would just replace that sine squared with 1 minus cosine squared. And you can also see that if you rearrange the equation a different way, you can always say cosine squared could always be replaced with 1 minus sine squared. So you just kind of manipulate it to fit your needs. Okay, now you can see I've got some kind of quadratic equation forming here. And we know that quadratic equations must always be set equal to 0. So I'm going to add cosine squared theta to both sides. And I'm going to subtract this 1 from both sides. So this side becomes 0, and this side becomes cosine squared theta plus 2 cosine theta plus 1. And again, you can see the trinomial relationship here. If this were x squared plus 2x plus 1, I'd factor it in x plus 1, x plus 1. X squared plus 2x plus 1. So I'm going to factor this one into cosine theta plus 1, cosine theta plus 1. And if you FOILed that back, you'd see you'd have cosine squared plus cosine gives my 2 cosine plus 1. And then you don't really have to set both of them equal to 0. They're the same thing. So this is just saying where is the cosine of theta, -1. And remember, you're solving for theta between 0 and 2 pi, inclusive of 0, not inclusive of 2 pi. So the only place where cosine is -1 on the unit circle is pi. So the only value of theta that makes this equation true is pi. Okay, let's take a look at one more. Okay, and again, this is another one of those examples where you see I've got cosine and sine in my equation. Sure, I could replace sine squared with 1 minus cosine squared, but that still leaves me with this sine here. So my best option is to replace cosine squared with 1 minus sine squared. So that gives me 1 minus sine squared theta minus sine squared theta plus sine theta equals 0. And combining up my like terms, I have 1 minus 2 sine squared theta plus sine theta equals 0. And I'm going to write it in my nice trinomial form, putting my quadratic term first. And I'm going to try to factor it, but I never like factoring where the leading coefficient is a negative. So I'm going to multiply both sides of my equation by -1. So that's going to give me 2 sine squared theta minus sine theta minus 1 equals 0. And then I'm going to treat this like a trinomial. So I'm going to factor it. So I'd have 2 sine theta and sine theta and a 1 and a 1. And I believe this one is negative and this one is positive. So quick FOIL back, that's 2 sine squared. That'd be plus 2 sine minus 1 sine gives me negative sine minus 1. Then set each factor equal to 0. And this gives me the sine of theta is a half, and the sine of theta equals -1. And so then you just go around the unit circle, and remember again you're solving for theta between 0 and 2 pi. So I'm just going to go around the unit circle and figure out where the sine is a half. seems we had this a lot. It's pi over 6 and 5 pi over 6. And where the sign is -1 is 3 pi over 2. And you've solved your equation. Okay, so try a couple of those and see how you do.